FLEETsters! Welcome to another episode of FLEETtv. This is Carla Ferrate with the Fleet Science Center. Today, we've got a great topic for you. You're wondering why I'm wearing this jacket? Well, guess what? It's because it's got one of my favorite patches. That's right. Astronomy is one of my favorite subjects. So, to start the day, we've got Andrea with a Fleet fail just for you.
Hi everyone, so good to see you again. It's Andrea, the Fleet Adults Programs Manager, and thanks so much for visiting me in my backyard in La Mesa. Last night I was out here in this hammock, all bundled up with a blanket, looking up in the sky to catch some of the shooting stars from the Lyrat meteor shower. And that got me thinking, I'm like, why does NASA never buy any blankets? Because they're super nice, they're cozy, they keep you warm when you do some stargazing. And then it dawned on me, because they have space heaters. Alright guys, have a great rest of the week. See you soon.
That was great, Andrea. Thank you for giving me a smile to my face. When you look up in the sky, have you ever wondered, there are some stars that look like they twinkle and there are other lights that don't. Do you wonder why that is? Dr. Lisa Will has got the answer just for you. Over to you, Lisa.
Hi, I'm Dr. Lisa Will, Professor of Physics and Astronomy at San Diego City College and the resident astronomer at the Fleet Science Center. One of the questions we received at Ask a Fleetster is, why do planets not twinkle but stars twinkle? And you might be wondering about that because Venus has been such a brilliant, steady beacon in the western sky the last few months. So the reason, well, there's actually two reasons: distance and refraction. Refraction is the process by which light bends going from one material into another. You may have noticed this if you've ever dangled your legs over the side of a swimming pool and noticed that your leg under the water doesn't really meet up with your leg above the water. This is also the same practice by which light going from air into glass bends and can come to a focus, the way magnifying glasses and your eyeglasses might work. So refraction means that when starlight comes from outer space, the relative vacuum of outer space, and then enters our atmosphere, the light bends. So that's refraction. How does distance play into this? Well, the stars in the sky, with the exception of the sun, are all so far away that they should just be tiny little points of light in the sky, really, really tiny little dots. So when the starlight comes in from those distant stars and it hits the atmosphere, it actually bounces around a bit. It goes from one little space to another as the light enters from space going into our atmosphere and then deeper and deeper into our atmosphere. It can also be affected by turbulence in the atmosphere, humidity, the way the light smears out. Instead of seeing one steady little point of light from a star, you're actually seeing a bunch of little pinpoints of light sort of moving around, and that makes the star twinkle to your eyes. Now, if you're an astronomer and you're doing an observation, taking photographs of stars, this actually means the starlight smears out into something that astronomers refer to as a seeing disk, if you want to look that up. So why is it that stars do that but planets don't? Well, although planets tend to be much, much smaller than stars, the planets in our solar system are so much closer to us that they aren't little tiny points of light in the sky, but they actually make little physical disks on the sky that you can see. And so when the light from those planets comes into our atmosphere and smears out a bit, it basically smears out over the top of its own disk already. And so it's not making the little different points of light coming out and smearing around looking like they're twinkling. Another way to say this is that a seeing disk for a planet is basically within the size of the planet itself on the sky, whereas a seeing disk for a star is bigger than the physical size of the star on our sky. So stars appear to twinkle and planets don't because of two aspects: the refraction of light coming in from space into our atmosphere, and distance. This is a fantastic question, and we hope you keep sending in more questions to Ask a Fleetster.
That was perfect. Now we finally can answer the grand question. Twinkle, twinkle, little star, how I wonder what you are. If they don't twinkle, we already know they're planets. Isn't that great? Another thing that's super beautiful that lives in space are nebulas. And our Fleetster in the field, Ryan Dodson, all the way from San Marcos, can teach you how to replicate one of those from home in our next activity.
Hello everyone, my name is Ryan. I am a Gallery Experience Supervisor over at the Fleet Science Center, and this is Evelyn over here. Yeah, so today's activity, we're going to actually make some nebula spin art. This is what it looks like after you're all done. So to make this, you're going to need a few things. You're going to have a salad spinner, paper that you cut out into circles that are the same size as the bottom of the basket. You can take out the basket and trace it on the paper to get an idea of the size that you need. You're going to need some sort of paint, and you want to water down the paint a little bit. I'm using tempera paint here, and it's about 3 parts paint, 1 part water in order to get it to spread nice and evenly across the paper. So in order to do this, we're going to go ahead and take one of our papers and put it inside our salad spinner. So Ellen, choose 3 colors. So you want orange, yellow, and blue. So we're going to go ahead and put a few drops of all these colors in the middle of the basket. So you want to make sure they're right in the middle in order to represent a star going supernova. And then when we spin it around, all of the gas that's inside that star spreads across and creates this beautiful nebula painting. Now we're going to go ahead and put on the top, and then Evelyn, you're going to be my supernova. You're going to make that star go boom. Ready? Go ahead and press that button down. Keep pressing it. There's a very violent supernova. There we go. Let it spin for a little bit. Hit the brake on your salad spinner and pull out your brand new nebula. Wow, is that pretty? You like your nebula?
Yeah.
Yeah. And then you can go ahead and name your nebula based on what it looks like. So like my earlier one. You want to call that one the Sun Nebula?
Yeah.
Yeah. So we have our Sun Nebula here. So nebulas are actually created from the death of stars. Most nebulas form when a star slowly sheds layers of gases over a long period of time. But every now and then, you can actually have a nebula formed from a supernova explosion. Stars are in a constant battle of forces. We have gravity pulling the star in and nuclear explosions within the star pushing it apart, and it's a balance. Eventually though, a star runs out of fuel. All the hydrogen inside of it gets used up, and when that happens, gravity wins the battle, and the star collapses in on itself if you have a really massive star, and it causes a supernova. So nebula spin art is actually a pretty good representation of how NASA actually has photographs of nebulas. When we have a satellite like the Hubble take photographs, it has a camera on board that has a filter in front of it that can isolate the different wavelengths of light. And this includes colors we can't see with our eyes, like infrared and ultraviolet. NASA takes all those separate images and colors them, and then compiles them together to create these beautiful photographs of nebulas that we see all the time.
Thank you, Ryan and Evelyn. Those look awesome. I know I'm definitely gonna make some, maybe for my living room, my bedroom, for my brand new office, in my kitchen. They would look great. So if you end up making them too, make sure to share them with us using our social media handles that are gonna be somewhere in this screen. I don't really know where. Also, make sure to like and share this video. And we'll see you next time on another episode of FLEETtv. Bye, Fleetsters!